Welcome to week 12, day 54 of the spring 2025 Web Technologies course. I'm Jim Kaufman with Rankin Technical College. So this week we are going to be covering chapters 13 and 14. Also, just kind of wanted to point out here, we're at the 75% completion mark of the course. By the end of this week, we'll be there. So time flies. Before you know it, we'll be wrapping things up. And I know that because we had a pretty good pace on a lot of the assignments. Things will kind of some of these assignments going forward, these labs, and this week we'll have some homework, the homework ones, and some labs, but they're not too bad. And I'll probably go through them pretty much, so that should be a little easier than probably some of the other weeks. We're finished with hands-on tests, so you won't have anything there. And in a minute here, I'll just go ahead and go through the course schedule, what we have left to cover. So I'm going to go ahead and go through the course schedule here, and then I'll go ahead and do a lecture and demonstration on Chapter 13. I'm going to walk through there's regular expressions. Chapter 13 includes regular expressions. And so I want to kind of walk through a few of them that are on the written test. We'll just kind of walk through how those work. And, I want to do a quick discussion also on debugging, just how to debug your code. Some of you might have a little more experience in that than others, especially for the students who were in the C# course. You kind of learned a little bit about that. And, maybe also learned as part of this course as well. But, some of the newer students, it's kind of hard to, there's a lot of different tools and, some of that stuff can be a little confusing. So I kind of want to go through that a little bit just to help you when you're trying to get something to work and it's not working. Sometimes it can kind of be hard. Just you're staring at the code, can't figure out what's wrong. Those, having debugging tools can help you out tremendously. And then besides that, I'm going to just go, kind of walk through of the Chapter 13 lab. It's kind of really just a hodgepodge of a couple different concepts. It's nothing too difficult. So let's go ahead and look at the course schedule. So we're at week 12 here, day 54. That's today. So we're going to do lecture chapter 13, which is about control structures, exceptions, and regular expressions. And I know some of that stuff we've already done some controls, a little bit of this, but kind of wanted to go through a few more concepts related to that, and then. Also, this will serve as a little bit of a review on some concepts as well. And then chapter 14, that'll be tomorrow, how to work with browser objects, cookies, and web storage. And this is how you can actually store things within the browser. And so we'll go through that. And this was, if you recall, for the midterm, we had for our little toggle to turn our page from light mode to dark mode. We actually used web storage to hold on to that value, and so it would hold on. So if you had it as light mode and you changed it to dark mode, you close your browser, you open up a browser again, it would be dark mode because that's what you selected the last time. It stored that, and it'll store that until you would clean. You're basically, clean your cache, right? Delete all your history and stuff like that. Or, actually it's not that, it's the storage part. But, if you get rid of your cookies and your stored data, then, it'll go back to default again. But, so that's kind of how that works. But, we'll be going through that tomorrow in depth. So then here on, so that was week 12. So here we'll be on week 13. One thing I did want to do and is kind of give you an assignment. I'm working on this. on Git branching and merging. So in the real world, when you're working on projects, you're working on a team, and a source code base, and in our case, we're using GitHub in that. So if and not everybody uses. There's other source controls besides GitHub, right? Um, but we're using GitHub, and a lot of places, a lot of companies, a lot of organizations do use GitHub. So Git and GitHub. There's other stuff is available as well, like I said. But what happens is when you're sharing a code base, you're sharing that code base with your whole team, right? So there's time, and there might be times where you've got, you're going to have like this main branch, and then you might have, your main branch, and then you're going to have, let's say that you're getting ready, you finish something up, and it's on the main branch, and that's what you're going to be deploying to your a production environment. But you're already ready to start some other coding. People just on teams aren't sitting around waiting for the deployment before they start coding the next thing that's part of the schedule to work on. So you actually make a branch off your main. You start working on that. Eventually, your main's going to get deployed to production. Maybe you got some kind of a cycle. You're waiting to deploy that, but you and the rest of the team might be working on a branch, okay? And then after that goes to the production, a little later on, you may merge that branch back into main for that to go into production, okay? So just kind of wanted to go through that a little bit just so you had a little bit of exposure. And I'd like to maybe in the second year do a little bit more of that just to show you about merging and that, because it's part of whenever you work on a team in a real world environment. That's going to be the case. And it doesn't really matter what kind of source control you're using. That's still going to be the case as well. So kind of wanted to go through. So I'm going to kind of give you a very easy assignment on that. So that'll be for next week. And then we'll go ahead and also we'll do chapter 15, which is arrays, sets, and maps. I know we've already kind of used a little bit of arrays in that, but so some of it'll be a little bit of review, some of it'll be some new stuff. And then as far as objects, I know I've seen some code where some students have used some objects here and there, but so we'll go into that a little more in depth next week as well. So after week 13, that will be pretty much the end of using our book. It'll be the end of the written test and the end of our book. So then week 14, we're going to go ahead and work on Node. So explain that to you when we get there. But basically Node, Express, React, and MongoDB. Them are things we do in the database one. So this is kind of a little bit of a preview of what you'll be doing in the database one driven class. That's going to be this summer. So just kind of give you a little introduction to that. And then there'll be some students that'll end up doing the C# stuff, but you still get a little bit of introduction then. And then when you do get into the ones that are going into the C# this next in the summer, whenever you do start the database driven one class, there'll be a review of some things before we start diving into things. So obviously it's easier when you take the HTML in this course, then you go into the database driven one. That's a little easier transition. But then also the C# course, the students that are in the C# course, when they finish that one, they've already done the HTML, then they did the C#, they will transition into database 2, which is related to the C# stuff. So that'll be easier transition for them. So easier transition, just depends on where you're at within the program. But so week 14, we'll work on Node and also Node and React. So we'll have some assignments on that. I'm still working on this. So if you end up going in here, this is probably going to be changed. This is kind of more what I'm thinking about. So just wanted to mention that. Okay, so yeah, I've got, I guess, basic like 2 weeks of Node and React assignments. So we'll be doing Node and React assignments for 2 weeks for the most part. And then after that, you'll have your final project will be the last week. And I know for you who were in the C# class with me last semester, we kind of did our final project earlier on and it was completed, and then after that we kind of we did a little bit of the Maui framework after the final project. So, but generally it's really in most of these courses the final project is the final project, right? It's what it's called, final. So usually it's at the end. In this case, it is going to be at the end. So just kind of, and I'll go through this later, obviously again, but so the final project's due on that final class day. So that's it, right? So once that deadline hits, which is going to be April 27th, that's going to be it for that. Okay, so that's just a month away. So okay, so let's go ahead and start this lecture here on chapter 13. So we're going to talk about control statements, control flow, exceptions, and regular expressions. So control flow is the backbone of any dynamic application. It dictates the order in which the statements are executed. Control flow, it's achieved through constructs like the if-else, the switch, the for, the while. All allows us to create dynamic behavior adapting to different inputs and conditions. So scenario where, for control flow, user logs in. When a user attempts to log in, the control flow determines whether the credentials are valid, username, password, etc. And if statement checks if they entered those that match that's, in this case, what's in the database, right? We're not doing that here, but, kind of what's done in the real world for the most part. If they exist, you're going to go ahead and let them move forward. If not, then you're going to have some kind of error messages or suggestions. This doesn't exist, or you need to reset your password, etc. Right? That's all you're using control flow. You're using your if-else statements, etc. Right? And as far as form validation, when a user fills out a form, JavaScript uses control flow to validate the input fields. If a field is empty or contains invalid data, an error message is shown. And the form submission is prevented, right? You prevent the form from being submitted if there's a validation error on the page. So as far as error handling is concerned, it's crucial for robust, reliable applications. Users expect software to be stable even when things go wrong. So the worst thing you want to do is you have an application that something breaks and the user doesn't. If something breaks, if something is wrong, then the user needs to be notified that something happened and why, or a contact number or something, right? You don't want to just click a button, nothing happens. You wonder why nothing happened when there might be an error associated. That's why nothing happened, but the user doesn't know, and they don't know how to, they're not developers. They don't know how to debug things, figure out what's going on. They just know it didn't work. And when that happens in the real world, especially like public type websites and applications, users just won't they won't come back, right? If things don't work, if they're not stable, they're unlikely to, be return users, right? So without error handling, unexpected issues could lead to poor user experience and even data loss. And it's just talking about error handling, some scenarios where, you want to handle errors is when you're, and some of the stuff we haven't done, and you'll learn more about it, in the second year courses, like API requests when fetching data from an external API, errors can occur. You can have a network error, the system could be down that you're trying to access. So you need to have try-catch blocks around that. Try-catch blocks around that data you're trying to do, try to access, and then you need to be able to handle them errors. Just, displaying a user-friendly message. You want to display a user-friendly message and preventing the application from crashing. You don't want, if there's an error, you always have to think, okay, if I'm accessing something and it's not there, how does my application handle that, right? So you always want to, that's part of your design approach. User input errors, if user enters invalid data, and you got to always figure that, a lot of times when we test our applications, we're always putting in, valid data, sometimes by accident invalid data, or, hopefully you are testing with invalid data at times. But, users will do all kinds of things, cut and paste images into things, this, that, everything else, right? I mean, anything goes. You get enough people hitting your application, your website, you're going to see all kinds of unbelievable things that, people do, unexpectedly, not on necessary, sometimes on purpose, and most of the time it's on accident, but, all kinds of things can happen. So you always have to plan for those kind of scenarios, right? And then also like loading images and or other resources. So, sometimes like your loading image, that image could, it's different. You have an image maybe that's local and you have in your directory structure, but if, what if you messed up and it didn't exist in your directory structure? Well, you want to account for that. You may want to display a placeholder image or something. If this image isn't there, you display a placeholder image, or whatever. And, especially when you're accessing maybe images from the internet, you may just have a link to an image that's on the internet somewhere. And as long as that image is there and, you've got a network connection, it'll work. But if something happens with that, then it's not going to work, right? So you need to always think and account for things like that, right? Then also kind of want to talk a little bit about pattern matching, right? So pattern matching, primarily through regular expressions, enables us to search, validate, manipulate text with precision. So that's basically form kind of type validations, and it may not always be form validations, but that's pretty much the major, the most what's used most often is with forms, but basically data parsing and text processing. So regular expressions provide a powerful and concise way to define complex search patterns, saving us from, error-prone string manipulation code. So basic like email validation. So, I know HTML, especially HTML5, has some built-in features for some of this stuff. And, that's fine to use, but there may be situations that you want to do something special in a certain circumstances, right? Obviously, you can have that on your, you can use those different things on your screen, but, you may want to do some additional validations besides just that default one like the HTML5 does, right? And you may want to do something different. You may want to give them certain error messages, custom messages, or, custom behavior based on what they entered, right? So there's different reasons you may, you might just use the HTML type tags for validation of different fields, but then again, you may use JavaScript in addition to it, or replacing it completely, right? And it's just kind of a couple scenarios, also phone number formatting, phone and email. Okay, so control statements. So in JavaScript, comparison operators are fundamental tools for evaluating a relationship between values. They return a Boolean result, true or false, allowing us to make decisions within our code. Now, we've used all these, but so this is kind of a little bit of a review. And, every once in a while we'll touch upon something that you probably kind of forgotten about or maybe didn't quite understand as well as you maybe should have. So we've got equality operators, right? That's different than assignment operators, right? When you assign a number to, like, say, a value to a variable, right? You use the one equal sign. That's an assignment operator. In this case, we're talking about equality operators, and we have the double equals and the triple equals, and then we have not equals and not equal equals, right? Let's see. Okay, yep, equals to and not equals to. Okay. So these operators perform type coercion, meaning JavaScript will try to convert the operands to a common type before comparing them. And I know we've gone through this before, so a little bit of a review. So here here you see we got a 5, the number 5, and we're comparing that to the literal value 5, right? This is going to be true because this is going to do a conversion. It's going to do a coercion, and this is going to return true, right? Here it's just showing with the same thing using coercion. Well, right? So you got 0. 0 equals false, and this is also false is going to be converted to a 0. A little different, and I don't think that we actually touched upon this one before, this scenario. So especially for the students who've been C#, you can't, it doesn't work this way, right? It doesn't work in languages like that, right? But in JavaScript, basically a 0 equals false. And I'm going to get into that here in a little bit more because there's this concept of truthy and falsy. And so we're going to talk about that here in a little bit more. So the problem, this implicit type conversion can lead to unexpected and undesirable results whenever you're comparing a number to a string value. It just kind of opens up the door for problems, right? For potential issues. So using the strict equal to is a better idea, right? So you got the strict equals to, and this is the strict not equal to. These operators perform strict equality checks, meaning they compare both the value and the type of the operands without any type coercion. So, these are actually, very good. I'm going to try to point out more going forward here. These are good interview related questions. You always want to these are the ones, you kind of always want to know different things like this. Have this in the back of your mind, all these kinds of things. So when you're in an interview, you can spit these out really quickly. The significance of the strict equality operators leads to more predictable and reliable code, eliminates the ambiguity introduced by type coercion, preventing subtle bugs, right? So when you've got your triple equal sign here, right, which is your strict equal, obviously the number 5 is not going to equal to a string 5. 0 is not going to equal to false. 5 will equal to 5, right? And then 5 not equal to 5 is going to return true, right? So that makes sense. And then, always remember the not equal sign is always the invert, right? The inversion of whatever it is, right? Sometimes, those not signs, exclamation point, can be a little tricky sometimes, especially when you got some complex stuff. You can just think it's the opposite. So you kind of just get rid of, if you just pretend it's not there, does 5, equal, right? 5, it's false, right? You already know that this is going to be false here. Then if you do the opposite of that, it's going to be true, right? So key takeaway, always prefer the strict equal, unless you have a very specific reason to use the double equals. Okay. And I know I've been guilty. I know a lot of people are guilty of, especially maybe some programmers been coding for a while, and they're kind of used to use the double equal sign instead of the triple equal sign. So it's very common, and I'm sure you'll see a lot of code when you at some employer at different employers. I'm sure you'll see a lot of code that will have the double equal signs. So real quick on our numeric comparison operators. Nothing special here, I guess. Just, 10 greater than 5, 3 is less than 8. Them are both true. 7 is greater than or equal to 7 is true. And 4 is less than equal to 2 is false. Pretty straightforward there. I'm sure everybody's got that down. Here's one that, I don't believe that we covered, which, it's kind of an interesting one. Just to let you know it's there. Is it the best way to do this? Yeah, I wouldn't think so, but not really. But, it's this lexicographical comparison where basically apple is greater than banana is false because it's basically, alphabetically, right? It's apple, banana. Apple comes before banana alphabetically, right? So apple less than banana will output true. Okay, this first one outputs false, right? These operators are essential for sorting, filtering, and making decisions based on numerical ranges or ordering. Well, yeah. I haven't done a lot of this way. I haven't seen that used often, but kind of done a little different way than this, but just wanted to let you know that this is an option. Depends on what you're doing here. Logical operators. Logical operators are crucial for combining and manipulating Boolean values in JavaScript, enabling us to create complex conditions and control flow of our programs. So we have the double ampersand, which is the and, we have the or, and we have the not. So the double ampersand returns true if both operands are true, otherwise returns false. Pretty basic there. I'm sure everybody knows these. Used to check multiple conditions. Yes. So in this case, you got two different conditions you're checking. If age is greater than 18 and is the value of this variable true, has a license, right? So pretending that there's a variable earlier on that has license. So if this is true and age is greater than 18, it will enter that block of code. And then here's the or, which is the double pipe. And here's the truth table for that. Pretty basic what we've done. Whenever one side is false, either the left operand or the right operand, if either one of them is false, it's going to return or. As long as there's one true, it's always going to return true, right? So if both are true, it's going to return true. Here, the left operand is true. It's going to return true. Here, the right operand is true. And then here, in this case, they're both false, so it'll return false. It's basically the only time it's going to return false is if both are false. Or if you have multiple. All of them would have to be false, right? And not inverts the Boolean value of its operand, right? So not true equals false, and not false equals true. So, sometimes I know that, for me, I've gotten confused before. So, that's why you always kind of look at it as being the inversion of it. So it's the invert of the Boolean. So not true is going to be false. It's always the opposite. Not false is going to be true, right? It's used to negate a condition, right? To negate a condition. And then the whole short circuit evaluation, which I know we've gone through before, but just has a little bit of a review. At the first, for an and, if the first operand is false, the second operand is not evaluated at all. And that's because it has to be an and. If the first one's false, it doesn't matter what the second one is, it's already false, right? So you don't need to check the other one, right? It's more of an efficiency, programming efficiency thing. And then for or, if the first operand is true, right? Because you only need one of them, or you could have multiple obvious operands here. But if once you reach the first one's true, or if you have multiple, once you reach one of them that is true, it's not going to evaluate the others, right? It's just looking for one. It's going to evaluate that statement, looking for a true. Once it gets to a true, it's done. It doesn't check anything else, right? So it's just, practically short circuiting can be used to improve performance and prevent errors. Yeah. So in this case, it's showing that, because let's say you've got an array or something, and you've got a dot length on that array, or, a string, and you've got a length on that string. Well, if you didn't define that string, maybe that string's null. If that string is null and you're doing a dot length, you're trying to get the length of that string using dot length of a null, right? That's going to be an error, right? So by using the short circuiting, what you can actually do is say if this object exists. So basically, if it's not null, if this object actually has a value, right? And that object.property, so in this case, some string.length, then this will prevent that error, because if it's an and, so if this is false, it's not even going to check this. So if this one would create a type error, right? This one would create a type error if the object doesn't exist by doing a dot property on a null object, or the object doesn't exist. This is going to be an error, right? Well, this is going to be an error too. But if the object exists and it's null, right? If the object exists and it's null and you did a length on that object, right? This would fail. But since you're doing it this way, this isn't even going to be checked because you've already checked it here. This is false. It's not even going to do anything here. So yeah, this is a very good practical use of using short circuit evaluation. Nullish coalescing operator. So what this does here, this differs from the OR in that the OR returns the right hand operand if left is any falsy value, right? The double question returns the right-hand side operand when the left-hand side operand is null or undefined. So basically, in this case, you got a username, which is null. And so if it's null, right, this is going to be null. This is going to display the name will be guessed. So if this is null, you're going to return that. Okay? That's basically what you're saying. So if username had a value, it's just going to be, in this case, it wouldn't even, it would return the username. It's not going to return this, right? Because the new username already had a new username. But if the username isn't populated, it's going to return guessed. Option chaining. We've worked on this. Allows safe access to nested object properties. If a property is null or undefined, the expression returns undefined instead of throwing an error. I know students in the C# worked with this a little bit. Maybe we'll touch upon this later. Probably not today, but we'll touch upon this when we work out with objects a little bit more next week. So this optional chaining, these operators simplify code to prevent common errors when working with potential null or undefined values, they make code more robust. So, in summary, logical operators are essential for creating complex conditions. Understanding truth tables is crucial for predicting outcomes of logical expressions. And, I've seen sometimes that I've seen coding requirements where they actually have truth tables. And so if this condition and this condition, they have actually, spelled out not just true and false, a little more specific than that. So if this specific scenario exists and this specific scenario exists, then, so I've seen, there's that's used sometimes in coding where you have a truth table for different conditions. And obviously it's, not basic stuff we're looking at, a little more in depth as far as specific about some certain conditions, right? But truth tables, understanding truth tables is a, good thing to understand. And then this short circuit evaluation can improve performance and prevent errors. So when they say improve performance, it's because you're not having to check everything in a statement. Basically for an and, if the first one is, if the first one is false, you're not even going to check the others, right? And for an or, if the first one is true, you're not going to check the others. So kind of that's where the performance part comes in. As far as preventing errors, like we were talking about that already, is the fact of if you have an object and you try to do a property on an object, well, in your if statement, you could check first to see if that object is not a null value first, right? Check that object first before you do a dot property on that object, and that'll prevent errors, right? All right. So, very conditional statements allow us to execute different blocks of code based on whether specific conditions are met. They give our programs ability to make decisions and respond dynamically. Just basics here. We've kind of, everybody I'm sure understands this because we've done a lot of this already. So just a quick example here on that. Let's see, chains multiple. This one here chains multiple conditions together. Switch statement. Yeah, so, do want to go over a couple things on this. So switch statements effectively handles multiple cases based on a value of an expression. So you gotta know when to use your switch statements. It's basically when you have a value, one specific value, and you have, if it's this value, you can relate that to one specific thing, right? When you're doing something like here, you're saying greater than or equal to, things like that, it's not going to work for a switch statement. It's got to be kind of absolute. If it's this specific value, do this. If it's this specific value, do that. Right? And basically, for a switch, you have a case, and then you have your break, and you have your default. So let's take a look at this one. So here, you got a day of Monday, and then, so you're basically passing in Monday, and then for case Monday, you're going to go ahead and log this, and you're going to break. So you're just going to break out of this, right? And I am going to here in a little bit, I want to go over when we look at some code here. We go over like chapter 13 lab. Kind of wanted to go over, because there's kind of like three different, well, there's more than three, but it's the three main ways to get out of a code is using a break, or a continue or a return. So I kind of just wanted to go through that to make sure everybody has a good understanding of that. So, but for switch statements don't have a continue, doesn't make sense. For like a loop, for a for loop or a while loop, right? A continue statement basically means go up to the next iteration, right? But for a switch statement, continues aren't relevant because you only do this one time and you're done. You make a decision, you pass in, your day here. You're going to match your case. You're going to, and in this case, you're logging it, and then you're breaking. Then you break, and all break does is make sure it doesn't check the other ones, right? So break is just going to break out of that, and you're done, right? There is no such thing as continue, and it's not a situation where you do a return or anything either. But I'm going to go through. I want to go through that with everyone here a little bit, just to kind of make sure everybody's on the same page with that. So some of the advantages of a switch over a nested if statements improves readability for multiple comparisons, potentially better performance in some cases, more concise syntax when dealing with many if-else conditions based on a single variable, right? But there's some certain circumstances it's not going to work for if-else statements, right? And other times it will, right? It depends on what data and what you're trying to accomplish. And then there's the ternary operator, where you basically have a condition, a question mark, and then you have, if the condition is true, the first one is going to be the one, it's going to select the first one, else it's going to select the second one, right? So this is a much more concise way than doing an if else. Otherwise, you'd have to do if message equals is raining, bring an umbrella, else enjoy the sunshine, right? But here you can basically just use this one concise statement to do that same thing, right? So it's useful for simplified conditional assignments or expressions. Obviously, if you got something really complicated, you don't want to do this. It's for just some simple ones. Yeah, this is the preferred solution to do that. It just says that here actually. Avoid excessive nesting of ternary operators that it can make code difficult to read. Okay, key takeaways. If else and if else are fundamental for decision making. Yes. Switch statements are ideal for handling multiple cases based on a single value. So when you're coding, that's something you think about, when you're coding. So is this always going to be a single value? Yeah, okay, I want to use a switch statement here, right? There's multiple cases, and I have a single value coming in, and I have multiple cases that can potentially take place. So switch statements would be, something you would do there. Otherwise, you do an if else, and if it's something really simple, just an if and an else, it can be very written very concisely on that line. You just use the ternary operator for a shorthand, right? So you want to choose the conditional structure that best suits the complexity and readability of your code. All right. So loops here. So loops are essential for automating repetitive tasks in JavaScript, allowing us to execute a block of code multiple times. Let's explore the key loop structures and control mechanisms. So, and all of these areas, all of these kind of basics we kind of talking about here within this, kind of more of a review than anything. These are all potential interview questions that it's good for you to kind of make sure that you have a good handle on these. So if there's any areas you can't remember, just sometimes it's a very good interview question. So they might show you there's a for loop. What does this mean? Well, the first is the initialization. Then you have this is the initialization. This is the condition, right? And this is the increment, right? And it's always good to know the different use cases, right? So when When would you use a for loop? Well, it's ideal for iterating a known number of times, or when you need to track an index, right? You always got your index. You always have your I. So that's a good reason to use it. Now, sometimes, you're not all, in this case, they've got a hard coded number 5 here, right? But, sometimes you're going to have a dot length, right? You might have a dot length here. And obviously before, when you have that dot length, you probably want to make sure before you even hit that for loop and do a dot length on whatever you're doing that dot length on, whatever object you're doing a dot length on, is it a string, it's an other object, probably want to make sure that it's got a value there, because if it doesn't have a value, you're going to get an error here, kind of like we were talking about earlier, right? You're going to get an error here if you try to do a dot length on an object, right? On an object that doesn't have, that's null. While and do while loops, difference in use cases. So the while loop executes a block of code as long as the condition is true. So as long as count is greater than 3, this is going to continue. Okay. You're obviously, one thing is you want to make sure that you're always incrementing your count within your loop, because if you don't, this will become, you get rid of this line, you'll have an endless loop, and your browser it'll just keep going, and eventually it'll blow up. Eventually your browser will freak out on that. And probably nowadays with the more modern browsers, it probably can handle a lot longer, surviving a lot longer than they used to. But eventually, if you have a loop, an infinite loop, you get stuck in an infinite loop, sooner or later, you'll get a little message that you got a problem on there. So a while loop, suitable when the number of iterations is unknown. Here, actually, that's not the case, but suitable when an operation is unknown or depends on a dynamic condition. A do while loop, similar to a while, but guarantees that the code block is executed at least once. So when you come in here, it's going to do this. It's going to do this even if this condition is not true. It's going to do this one time. Then it's going to check to see if this condition here is true. Right? If it is true, it's going to keep continuing until it's false. Right? Until it's false. Use cases, useful when you need to execute a block of code at least once, regardless of the initial condition. Break and continue. Yeah. So here, and that's what I was kind of referring to earlier, and but we can kind of look at it right here. So basically here, what this is going to go ahead and do, this break here, this break really has not so much or anything to do with your if statement. It has to do with your for statement, right? So this is going to, whenever you have a break, it's going to terminate your loop immediately. So you get here, if I equals 5, it's going to terminate, it's going to break here. So it's going to terminate this loop, and then it'll stop right there. It's not going to print this again, right? It's going to terminate your loop. Where continue skips to the current iteration and proceeds to the next one. So if I equals 2, it's going to do continue, and it's not going to do this that time. If it's equal to 2, it's not going to do that. It will continue. So in this case, you're starting at 0 here, it'd be 0, 1, and then when you come to 2, it's going to skip 2, and then it's going to go 3, 4, 5, right? Or 3, 4, right? 0 through 4 is 5 of them. Continue is going to continue the next iteration, right? And I did want to also note, just mention that, and not really probably don't want to do this way. You just got to return. Sometimes you can do like a return statement. It's going to return from your whole JavaScript, right? It's beyond. It's outside of the scope of just a loop, right? It's a return, just returns the from that. And I've seen times when people have made mistake, confusions between a break, a continue, and a return. Okay, so you need to know when you're using, what each one means and when you want to use one or the other, right? So use cases break is useful for exiting loops early based on specific conditions, while continue is useful for skipping certain iterations. Okay, I'm going to talk about truthy and falsy values. So this is one thing different about JavaScript as compared to other programming languages. Java, besides C# and Java and many others, is basically, either something's true or it's false. Well, it's a little different for JavaScript. So, you know, uh, especially when you're got an if condition and you're checking that, you're checking something. If you're checking something that's false, is going to return false. If you're checking a zero, zero is going to return false, right? Or falsy, right? Look at it, it's falsy. False is going to return false. Zero is going to return falsy. An empty string is going to return falsy. A null is going to return falsy. Undefined and not a number are going to all return falsy, okay? These values evaluate to false in a Boolean context, right? So they're all going to evaluate to false. So you can there's some benefits in that where you can kind of check those different things. Basically, you say if this has a value or if this is a real value. Is this a valid value? Null's not a valid, an empty string is not valid, You can check to say, does this exist? Does it have a value? All of those together, right, is basically a check for truthy and falsy, right? So for truthy values, any value is not falsy. True obviously is going to return true. One or any other number. It doesn't have to be the number one. This is an example. Any number, basically, if it's got a value, right? If any kind of a number, any kind of a string, right? Any kind of a string, even an empty, like an empty array, right? This is an empty array, right? That's going to return true as well, or even empty curly braces is going to return true as well, right? Loops are often rely on truthy and falsy values to determine their continuation conditions. Example, while some variable will continue as long as some variable is truthy. Yeah. So a lot of times like in a while statement is, your condition time is, well, is this val X is greater than 5 or something like that. But, it can also be something where you've got a string, right? And if the name, so, you keep looping until the name has a value, or, that one probably doesn't, that's probably not a good example, but it could be anything, right? You're going to keep on, you're going to stay in this loop while something is true, right? As long as it's true, it'll stay in the loop, right? Until it becomes false. So here's some falsy values, like we were just mentioning. False. So basically, this in this case, this won't print, right? So the only way you're going to be able to do anything within this block is if this evaluates to a true, right? If your if statement evaluates to a true. False doesn't evaluate to a true, so it's going to print this. A zero is going to evaluate to false. A empty string, right? Now this is different than a space, right? That's an empty string. An empty string is going to evaluate to a false, so this won't print for that one either. Null, a null is going to evaluate to false. Here we got a variable that you created. It's undefined. You didn't give it a value. So an undefined value won't print either. Undefined is also returns a false. Evaluates to a false. Not a number, evaluates to a false. Okay, then obviously true is going to evaluate to true. Any kind of a number, doesn't know any kind of number, um, and even a negative number. You know, sometimes you can think, well, it's a negative number. You know, you might want to question. You know, no, but a negative number is it's a value. So if something has a value, it's going to be true. It's going to evaluate to true, right? So any non-empty string, in this case, hello is a value, so it'll print. Here, just having a space. Having a space is going to evaluate to true. A space is real, right? It's something. You might not see it, but it is, right? It's a space is something. So any object, including empty objects. So in this case, you got curly braces. So that'll, not that you would do that, you know, not that you would do that, but just it's kind of just for your own knowledge that that's the case that works. So here property value, you know, object with a property of truth. Yeah, okay. Here's basically an array. This is an empty array, including empty arrays, but empty arrays is still an array, right? Even though it's empty, it's an array. It's kind of, you know, a little strange there, you know, but an empty array is also would also be truthy. Like I said, when would you kind of do that? You know, I don't you know, I don't know where you'd be in a situation to do that, but I guess it's possible. Anything has a value is always going to print. Item. So in this case, just showing you an example using truthy, falsy in a loop. Let item equal my array. If item is truthy, is falsy. So it'll have an item. So examples using truthy for logical operators, test and null. And, you know, this is your two conditions. So here you've got test. This evaluates the test. This one is null. So obviously this is going to, both values are truthy. Won't print because other value is falsy. Okay, got it. No, I wasn't reading it. Yeah, it's not going to print because this one's false. I was getting confused. I was thinking, oh yeah, it's kind of saying it's going to, I didn't even read this. Yep. So basically, yes. So this is going to return true. This is going to return false. So this won't be printed. So here you got some value or, so basically ors, obviously, all you need is one of them to be return true. Some value is true. It's not even going to check this one, and it's going to go ahead and print that log. If the opposite of value, this will print because other value is falsy. Yeah. Yeah. So, you know, that's where sometimes you kind of get a little confused on things like, especially the not sign. So it's always the opposite. So you always know that other value is false, right? It's null, but it's going to evaluate the false. So what's the opposite of false? True. So this will print. This will print because other value is falsy. Well, the opposite is basically, yeah, other value is falsy, but you're doing the opposite of other value, which is true. So key takeaways from truthy and falsy examples. Falsy values are those that evaluate to false in a Boolean context. Truthy values are those that evaluate to true in a Boolean context. JavaScript implicitly converts values to Booleans in conditional statements and logical operations. Knowing the difference between truthy and falsy values is critical for writing accurate and efficient JavaScript code. So key takeaways about the loops that we discussed earlier. For loops are for known iteration counts. And that's not always the case. Sometimes I guess you have a length on something and you may not know, but obviously if you do know how many times something's going to be iterated through, you definitely want to use a for loop in that scenario. While and do while handle unknown iteration counts. with do while guaranteed at least one execution. Break and continue, control loop flow. Yeah, it's basically saying breaks and, a break or, and a continue, control loop flow. Understanding truthy and falsy values is crucial for loop conditions. All right. Okay, so introduction to errors. In JavaScript, as in any programming language, errors are an inevitable part of development. They can arise from various sources, such as incorrect syntax, unexpected user input, or network issues. Effective error handling is crucial for creating robust and reliable applications. Why error handling is crucial: it preventing crashes. Unhandled errors can cause applications to crash, leading to a poor user experience and potential data loss. Providing feedback. Error handling allows us to provide information feedback to users, helping them to understand what went wrong and how to fix it. Maintaining stability. By gracefully handling errors, we can ensure that our applications remain stable and continue to function even in unexpected situations. Debugging. Error messages provide valuable information for debugging and identifying the root cause of problems. So it's always good to have console.log statements in your code. Let's see, common error types. So there's four different ones here listed: syntax error, reference error, type error, and range error. So syntax error occurs when JavaScript encounters invalid syntax, missing a semicolon, mismatched brackets, etc. So in this case, this is missing a closing parentheses. Then we have reference errors occurs when trying to use a variable that hasn't been declared. You got to make sure that you declare your variables before you use them. Type error occurs when an operation is performed on an inappropriate data type. Calling a method on a null or undefined. Trying to get a length of a string that's undefined. Give you a type error. Range error occurs when a numeric variable or parameter is outside of a valid range, like new array -1. So here, let's actually do that, because that's just for the heck of it here. Let's drop that in here somewhere. I'm surprised. That's kind of weird. Sometimes, I've kind of noticed here, I imagine most of you, with your browsers, I guess most of you are using Chrome. They get updated regularly, and sometimes I see different error messages pop up that didn't used to. So a lot of times, what you can kind of actually do is, especially if in this case, I'm dropping a value in there, but if you see some error messages that kind of don't look like it has anything to do with your code, for the most part, kind of probably in most cases disregard it. Sometimes there's other error messages that can happen. Especially here, I'm actually using this new tab, which does have some base stuff in here, and it probably has a little bit of reason for that. Sometimes you'll see some things that you don't expect, right? But here, I dropped new array in here. It says invalid array length, right? It can't be array can't be a -1. So try catch, finally. So those of you who from the C# course, you already pretty much have experience in this, but a try block encloses the code that might throw an exception. If the exception occurs within the try block, execution immediately jumps to the catch block. The catch block handles the exception thrown by the try block. The catch block receives an error object containing information about the exception. The error object has two key properties, a name and a message. So here's an example. You got a try and a catch. So here you're using a undefined variable and you're trying to do call a property on it, right? So you're trying to do a property on this undefined variable, and this is going to be return an error, type error. This will throw a type error. So this catch block is going to be executed. It's going to go ahead and print this console out message. And for us, we're programmers, we're developers, we just throw something out to the console. But for when you've got users, you got users that, they're not developers, just your basic users that's using something you're building, you need to have some user-friendly messages that come back to the web page itself, right? Like we've done before, obviously. And then a finally block executes regardless of whether an exception was thrown in a try block or not. It's typically used for cleaning up tasks, such as closing files, releasing resources, stuff like that. Now, basic native JavaScript can't do a lot of different things as far as like opening and closing files and stuff. But, you can make calls to outside APIs. You can make calls to external things from your application, your website. And if that returns an error, returns something, or you can't access that, then that's where you want to go ahead and, obviously you want to catch that. But, there's might be some situations, there's ways to actually call a database and stuff like that. If you're calling a database and you can't access that data, you've got a connection to a database and then you want to close your connection off, right? But it's a little different with just using native JavaScript. When we start doing things especially in the year 2 with the database-driven 1 class, we're making database connections and stuff like that. It'll be much more relevant using the finally blocks when in that situation. So here's an example of a code demonstration error handling for dividing A and B, where basically B is you're dividing by 0, and so if the B that you're passing in is a 0, it's going to throw this error, right? So it'll throw this error, and it's going to go ahead and drop over into this catch. It's going to catch that error, and it's going to return null, right? It won't execute this, right? So if B equals to 0, it's going to throw this error. It will skip this. Once it throws it, it automatically comes into this catch. It'll print this error message to the console, and it's going to return null. And then also, so if you run this, you'd actually see the error message, and you also see a division operate this as well, because it's finally actually, I'm betting we need to take a look at this one here in a little bit. I'm going to grab this and hold on to this because I'm kind of wondering, I don't see, if you return null, you're returning it. Is this finally really going to be in JavaScript? Because JavaScript does things a little differently, and it does have that return. I'm just kind of wondering if it's going to actually skip that finally. It'll be because it's returning null, and I'm just kind of wondering if it's going to end up returning it before it execute this. I've never checked that out before. JavaScript's a little different, but I'm going to check that out here in a little bit. Here's just an example. Throwing exceptions. Sometimes we need to create and throw our own custom exception to handle specific situations. So here in the situations, you're basically doing, if the type of the input is a number, then throw this type error. And so you're creating this new custom exception in this case. And this is basically a try catch around this method, this function call, validate input. So use cases for custom exceptions. Reason you might want to do this is for validating user input, handling specific application logic errors, right? So in both those cases, well, especially validating user input, you might throw some specific exception that one's going to be back, end up return back to the screen for the user to be able to correct something or make an adjustment. Signaling exceptional conditions that require special handling. Creating more descriptive error messages. Improving code readability by clearly indicating error conditions. All right. I know this is maybe a little grueling, but we're kind of on our last subject area here is the regular expressions. And so we'll go ahead and go through regular expressions, and then I think we're going to go right from them regular expressions to the written. There's, I think, three there might even be more than three, but three that there might be some other questions in that written test to do with regular expressions. But as far as the actually understanding how to decipher that regular expression, we're going to go through three of those that are in that written test. Just so you understand how to walk through those. So regular expressions are powerful tools for pattern checking within strings. They allow us to search, validate, manipulate data with precision, significantly enhancing our ability to work with string data. So the purpose of regular expressions, you've got pattern matching, text extraction, test replacement. With pattern matching, finding specific sequences of characters within strings. Basic validation, ensuring that the user input or data conforms to a specific format, such as like an email address or phone numbers. And then text extraction. You may use a regular expression to pull out certain text out of maybe a sentence, a paragraph, or whatever. So you can use regular expressions to extract specific portions of text from larger strings, and then also you can use it can be used for replacing substrings that match a pattern. So you can replace you use a regular expression to find it, and then you can replace it with a different string, right? Creating regular expression objects. Enclosing a pattern with forward slashes. So example here. So basically this is saying, this is enclosing this by you doing the forward slash and then a forward slash at end. That's signifying that, hey, just by saying this is a regex, this is just a variable. You can call this anything you want to call this, right? This is just a variable. But by you putting a forward slash and an end slash there, you're saying, hey, this is a regular expression. The I is for ignoring the case, right? So that's for ignoring the case. Could be, doesn't matter if it'll match if it's uppercase or lowercase, right? All right, and this is just showing using an object. You can actually create objects with your pattern and flags. We're not really going to do a lot of that, but this is just one way to do it. Okay, this is one way to do it. Here, the regular expression methods. JavaScript regular expression object provides several methods for working with expressions. So in this case, all right, sorry. So in this case, you create a variable, regex, and you use the forward slashes. So you're basically saying, look for hello, right? Here's your string that you're checking it against. And you can use this test. And then basically you're saying, does this string right? Does this string contain this regular expressions? If it does, return true. Okay. A match returns an array containing the matches found in the string, or null if no match is found. And if the G flag is used, it returns an array of all matches. Otherwise, it returns only the first match and its captured groups. So if you're like in this case here, you've got a / and then slash, so you're saying this is my regular expression. Here's the last thing here. This is your flag. And your flag is global, which means match all the O's, right? So it's going to match the O in hello and the O in world. If you did not use this G flag, it would only match the O in hello. And since we're using it just showing the output, you're gonna have two of them, the one that's in hello and the one that's in world. Search returns index. So this is returning a value, a number, right? Returns the index of the first match found in the string. It's going to be just the first one. Or a -1 if no match is found. So in this case, you got world and you got hello world. So basically, it's going to return where is the position of world. Basically, start. You know, if you're using a one character, then it's going to be that position of that one character. In this case, where does this start? And it's going to be 0 base. So here's 0, 1, 2, 2, 3, 4, and also a space counts 5, and the 6th one is going to be the W, right? So this will return a 6 is the match. So regular expressions are made incredibly powerful by flags and in meta characters. So the I is for case insensitive, right? So this will match upper or lowercase. It will match any 3 of these, or or in a camel case, uppercase, lowercase. G finds all matches in the string, not just the first one. So if you don't have the G flag, it's going to just grab the first one. M is for multi-line, enables multi-line matching in case you're maybe using it against a whole paragraph. It's on multiple lines. You want to use the M flag. All right. So here's the different meta characters. This first one is caret, matches the beginning of a string or a line. The $sign matches the end of a string or line. The dot matches any single character except new line. An asterisk matches 0 or more occurrences of the preceding character or group. The plus sign matches 1 or more occurrences of a preceding character group. The question mark matches 0 or 1 occurrence of a preceding character group. The backslash escapes special characters or creates special character classes. And we'll take a look at that here in a minute. The brackets matches any single character within the brackets. When you use a hyphen here within a bracket, this is a character range. So this is going to match anything A through Z. And this is only going to be lowercase, right? When you do a \D, this is for a digit, matches any digit 0 through 9. \W, any word character. \S is for white space. Here you're using a quantifier. These are all quantifiers, and if you're using the curly brace, it's matches exact number of occurrences. So you may just want to, how this kind of works is you're You're matching, like for a phone number, you've got area code, which is going to be a 3, right? Three numbers long, right? So you'd have a number 3 in there, right? By using the N and a comma, this matches one N, the number you put in here, so maybe 3 or more occurrences, right? And then here you would have, basically you're using 2 numbers, maybe starting, would be 2 and between 2 and 5 occurrences, Examples of complex regular expressions. This is an email validation. And I know these can be kind of complex. We're not going to have to don't worry about having to figure all of these out. We're going to go through a few that's in a written test. I'm going to go through them with you. But, these ones like phone number, this becomes a little more, once you kind of really understand that, it's not a big deal. It's basically saying any lowercase letters for, the first, any lowercase letters, any uppercase letters, any numbers, right? Also including underscores, right? And then having an @ sign. An @ sign has to be there. And then you're basically doing the same thing here on this as well, right? A lowercase, uppercase, a 9, and also a dot. It's including a dot as well. But, this is kind of, I know this is hard to understand. And it takes a while to understand that. We're going to go through some that are easier than that. We'll go through the phone number. We'll take a look here at a few, like I said, with the written test. Here's a phone number one. Basically, you're saying 3 digits. This is basically the area code. This is the first 3 numbers after that. And then here's your last 4 numbers, right? And this is a URL. Yeah, these are very complex, So, and always remember the last part of these, especially when you got a forward, wherever you use these slashes, these forward slashes, saying, hey, this is my regular expression. Remember, anything after that are your flags, right? Anything after that are your flags. Your flags are basically I, G, and M, right? In this case, you're doing an M and a G. Okay. So let's go ahead. Let me pull up the written test here. Okay, I'm going to go through these 3 of these questions that are on the hands-on test. Or not on the hands-on, on this written test. So 28, 29, and 30. So on 28 here, let's go through this. So which of the following patterns can be used to validate a 5-digit zip code? Okay. So the first one here, let's look at this one. So this pattern uses a character class D5, which means it will match any single character that is either a D or a 5. When you put so this D here, not to confuse, when you want it to be a digit, right, you have to do it like this one here. This, when you do this \D, you're saying this is a digit, okay? When you just put a D in here, you're just treating this like this is any letter. This could be an A, B, C. You're treating it as a string literal. So all you're basically saying here on this one is you're basically saying, this will match either a D or a 5. It does not look for 5 digits. and it's not looking for 5 digits at all. It's just saying a D or a 5, right? So this one's not going to work for us, right? So the second one here, that was that first one. The second one here, the plus means one or more plus signs. Well, we're not using plus signs, so that's not good, right? It's not a valid zip code character. The dash D means a single digit, right? Means it's a digit, right? And then you got your 5 here. Yep. Well, yeah. You're basically saying a single digit of 5, so that's not going to work either. This pattern would actually match something like a 15 or something like that, right? Now the third one, right? The third one, this symbol, the caret symbol, asserts that the start of the string. So you're saying you want to start at the beginning of the string, and it ensures that the pattern matches from the very beginning of the input, right? The backslash D, this represents any digit from 0 to 9, right? So whenever you want to use, there's these special characters like the W and the D, and to use those, how to separate those out from just being the letter D or the letter W or whatever, you use the backslash, right? So you're basically saying, by using this backslash, you're saying we're using what's the meaning of D, which is a digit, right? Instead of the string literal, right? You're using that functionality. So in this case, you're basically saying a digit representing any, and then this 5, right? This 5 that's in the curly braces, this is a qualifier that specifies that the preceding element must appear exactly 5 times. So that's for a zip code. You want it to be 5 times, right? You want it to match 5 times. So C would be the correct one here. Okay. And then you can see what's wrong with this one here. You've got the caret at the end. You only use the caret at the beginning. Caret symbols asserts the start of a string. So, you're usually going to have that at the beginning there. Okay. But, you could get this by process of elimination anyhow, knowing that whenever you use these brackets, that means, you're only matching 1 digit here. You're not matching 5. Here for zip code, you get 5 digits. So if you need to match 5 digits, you need to have this in these curly braces, right? So it's pretty much by process elimination, you can figure that out as well. Okay. So 29 here, let's look at that one. So this one here, so process elimination here. First thing, you just kind of take a quick look at this thing. You're starting at the beginning. So here you've got some brackets here. You got a bracket here, right? So zero through 3, okay? And here you've got a curly braces with a 4, so this last part here, right, is going to be, you're going to have, it's going to match 4, you need 4, right? Not the number 4, but 4 different numbers, right? So basically you're saying that here's your month, here's your day, and then here's the year, right? So by process elimination, you can actually get rid of the first one and the third one because you need your 4-digit year, right? So you got this one and this one, right? And here you're not using any you're not using any dashes, so this is not going to be relevant. So the answer to this one is going to be D. Okay. And I also want to point out when you're wanting to use like something in this case, you've got forward slashes in your text string, right? And if you got forward slashes in your text string, you need to use a backslash on those. And that's basically what you're doing here on this. You're saying you want a slash, you want to match a slash, right here, and then you want to also match the slash here, the forward slash. And the way to do that is because this does have a special meaning, right? Kind of like this has a special meaning, right? This is your beginning of your string. This is the end of your regular expression. I'm sorry. This is the beginning of your regular expression. A forward slash is the end. Now you've got this other one in the middle. So what you're saying here on this has nothing to do with the beginning or end. By you doing a backslash, you're saying, oh, I want the literal value for slash, right? And the same thing here. So you know you're going to have slashes in there, right? And then obviously you're going to have your 4-digit year. So D is going to match that one. Okay, and then this one here, let's see. So let's see here. So process elimination on some of this stuff. You got some letters in here. You got an A, capital B, capital C, right? You got digits here. Digits are numbers, 0 through 9, right? So you know that one's not going to work. You know this second one's not going to work because that's all only has digits, right? So then the last one to look at would be this one. So basically now you're down to 2. Is either this one or it's going to be your else not valid. And so let's look at this. We've got a forward slash to signify this is the beginning of our regular expression. We have an end slash to designate this as the end of our regular expression, right? So that's good. We got our caret. We're doing our backslash W. So that's basically saying a backslash W are alphabetical letters, or alphabetical numbers, right? So here you're saying a single letter, and you're saying I want 3 digits. So that matches your A and your 3 ones, a letter and 3 digits. And then we have a dash, and then we doing the same thing here, and this happens another time as well. So this would be the correct match. This would be the correct match for this. And so this looks good to me. I think that this is the correct answer here. So I would be choosing valid 3. But for any of these questions, there's other questions to do with regular expressions in here. Make sure you know the escape character. Which one's the escape character? And here over on the right hand side, this is basically the study guide. So it has all of those in here to help you as well. Okay, it has all of those in here to help you as well. So, all right, let's go ahead and look at that. I want to talk about debugging a little bit, and let's look at that lab while we're discussing that. So what you see here is pretty much what you need to be doing for the lab assignment. So, if you want to come back, if you want to look at this will help you pretty much with that lab assignment, help you out. Kind of did want to talk a little bit about debugging while we're doing this. So, basically as far as, a lot of your different assignments you've already done, I've helped some students with different things, different challenges they're having. And one thing that's really beneficial, obviously using those console.log files to print out things. But, basically I'm just going to mess something up just so we can kind of debug that. So, that's not valid. That's not a valid thing there. So you come in here, I'm going to put some numbers in here. It don't matter because should blow up. So obviously he's changing that. It's going to load that. It's going to be fine loading that, I believe. But so that's that there. But when I go ahead and click process numbers, here, let me make sure that that's correct. So let me just refresh this and hit 12 here. Yeah, it's not going to complain, and that's what I expected. So here, I'm just going to put in one number. That's all I need. So here, basically, so if you're working on an assignment and you got your code and you do something, you're expecting something to happen, it doesn't happen. Probably the first thing you probably really want to do is check developer tools, right? So hit your F12 key, and right here it's telling you that your number, that this is incorrect. This is not a function. Push 4, right? Push is a part of it. It's a method. It's a function for arrays, right? So that's kind of the first thing you want to do. If you got a problem, you don't see anything, first thing to do is go to developer tools. See if you see anything in the console log, right? That'd be like the first thing. All right. Let me refresh. This should be good now. So that's the first thing you want to do. And then if for some reason you're getting the wrong stuff, or let's see here, I'm going to change that. So here we're expecting here. I'm going to hit process numbers. Nothing happened. Even if I hit developer tools. Okay, yeah, it's complaining down here. So now it's saying here we've got a dot value. Well, the dot value is why? Because it doesn't exist. This doesn't exist because I changed it to the wrong one, right? So there you go. That helps you debug those kinds of things. So on top of that, if you're wanting, if you did something and you didn't like the results, or you didn't get the results you're looking for, and you don't see anything in the console.log file, and you think, well, it's still not working, but I don't see anything on console.log. Well, what do you do next? Well, one thing you can go ahead and do is, and I showed you this before, and I know maybe some students are doing this. I don't know. Some are, some aren't. Obviously, in here in developer tool still, you can use the debugger in here as well, right? So if you want to, here's process numbers. I can put a breakpoint. You can put a number in here, and that's going to go ahead and execute that breakpoint, right? You can also, let's see, in here, here you can actually, so it's just showing some stuff that's already there. And I know this is kind of a lot, and kind of a little bit, maybe a little overwhelming, but the more you do it, the more you play with it, the better you'll get at it. And it's a very valuable tool. So here I'm just adding a new watch, not available, right? Because we haven't gotten there yet. So here I'm down here, and I can go ahead and go to the next line. And now I'm split that. I'm going to walk through what all of those are. Now it's got a value, right? So you can inspect those things. You got a value of 3, right? Length of 1. So this is basically the 3 you put. So, this is a very powerful tool for you to go through, especially if your code's not executing like you expected. Walk through your code. First do a visual, see if you see something, that sticks out, quickly. But, if you're not seeing any errors in the console.log files, log file, then you might want to use the debugger to start trying to debug things. Now, this is one way to debug it, right? That's one option. So let's look at another option here. Now another option you can do here is you can use the debugger that's kind of integrated here with Visual Studio Code. So if I put a breakpoint here, and I hit, let me see what I have. There's different ways to do this, and I just want to make sure I don't tell you the wrong thing. So here, and then if you just hit the F5 key, hit the F5 key and choose, you should have an option to choose Web App Chrome, right? Choose that, all right? So what this is telling you to do, so let me explain something. It depends on where you try to start debugging from, okay? So this is one way to do it. So I started trying, let me just kill this for a minute. Let me get back here. I want to kind of review this a little more. This is a really powerful, very helpful tool for you to be able to work things. If I do it from the script.js file, okay, if you do it from there and I hit F5 and I hit web app, it's going to go to this launch.json file. And this is what I generally do use, okay? But here, what you'll notice is you'll have this URL. It's got 8080. Well, you want this to be the same as your virtual server, your live server. So you want to change that to that, okay? Now I save that. I can close this and come back here again. And now I can hit F5. But what it will do, it's going to open up a new window, right? So, but this is your job. This is the one that's tied to your debug session. Here's your controls for your debug going, right? Once I have a breakpoint right here, okay? And so once I hit that breakpoint, which I haven't yet because I haven't entered anything, then, I'll be able to walk through the code. But so now I've got this. If I go ahead and enter some data, hit process numbers, it's going to stop at that line number 3 over here, okay? And then obviously you can see this is enabled up here. You can walk through things, okay? Before I start walking through some of this in the debugger here, kind of want to go, just go through a few more things. One thing is to get rid of this, to kill this, okay? To kill this, you can either close your browser, this little browser window. And as you notice, you've kind of got it open and you've got this local host over here, but this window here is tied to this debug session, okay? If I hit this X here, it will get rid of this up here. The other way is actually to stop it from here. And you always, whenever you use the debugger, you want to make sure that, when you're done, you close it, or, just be careful because sometimes you get confused and it's still running and you're trying to do other things. So you might still be stuck in a debug mode. So if you close that, that will get rid of, let's make sure it did. Yes. So that closed the window. Okay. And this is how I kind of use mine, but there is another way to do this. I don't want to confuse things, but I just kind of wanted to show you this anyhow. So if I get rid of my launch JSON file, I'll move that to recycling bin. If I go over to my index, so I started my debugging session from in here. And probably the reason this is a little bit of a different scenario is the debug can work without the live server stuff. But if your live server is there, you can also use that port where your live server is, right? In that first instance, I was using it where that live server is, but you don't even need to do that. We can even close this, get rid of live server completely, go over here to the index. You got to make sure that you get rid of your launch config, which I deleted. And over here, I can actually hit F5 here. It'll open up this window. The thing that's going to be different now, though, is you can see it's actually just pulling the file from your file directory, from your directory. right? But you do have to start this, like I said, within the indexed HTML. You have to hit the thing there, because I'm almost sure if I don't do that and I try to do it from here, if I try to do an F5 here and do Web App Chrome, but it might still, yeah. Yeah, it did. It lost that. So, okay. So what you need to do, like I said, so here you always need to make sure you have at least one breakpoint, okay? And then you can come in here. So without doing the visual code, without doing the launch, without it using live server, you can just come in here, hit F5. It's going to bring up this. You can put in your values and hit process numbers, and it's going to stop at this line, okay? So for the easiest way to do this outside of live server, this is all you need to do, okay? But make sure that make sure that you're in the index.html, because you'll have some problems if you try to start it from your JavaScript file. But if you're into your index.html file and you hit F5 and choose your web Chrome, then it should open up this at the file path level, okay? And so you'll have this here, there, okay? Now let's kind of walk through this a little bit. And maybe some of you already use this, I don't know. But just kind of wanted to bring this up just so, just to help you when you're working on your assignments and you come up, something ain't working like you expected, you can do this, right? And then you can go ahead and click over here, and then basically you can look at the values of everything. There's your value. I put in a 3, 5, 45, and 90. And you got your values of everything. So that way you can walk through your code and see what's happening. And this is something you just kind of get used to. Now, and you can always do that. Now, even though you come over here and you can see your values, sometimes you just want to have them. You might have something you just want to have over here and watch, so you can do that as well, right? So basically, you can click watch here and add it. And you can be looking, sometimes if something's changing, here, you can just hover over it, you're fine because you already got it. But if it's something that that's getting changed a lot, maybe like the sum's getting changed a lot, I could go ahead and, I don't know why I did that, sum, and then, so this is telling it's because it hasn't been defined yet. But as we move through here, this is just iterating through here. It helps, this helps just to learn things, and even to see your variables get incremented and stuff like that, it's beneficial. So let's even look at that. So right now it's 2. So let me even start over. And I'm going to just go ahead and process numbers again. Get this out of the way. Okay. So you can see once we get here. So you can see when you go to this for loop, and loops are always good to go for debugging purposes, to go walk through them. And so here, step into, you hit step into it, goes through every little thing. And so it actually, it assigned a value to our I over here, right? And now, so once it's done, it's just going to go to the next thing that's available, right? And then step into, now it's back to here. As you can see, we set I to 0. It did this line, I still 0. So it just kind of helps you see how things happen, because it's not going to increment this I until after, it doesn't increment that I until after that line's completed. Just things like this kind of help you see how things work, right? It kind of gives you a little more insight to things. So if I hit into here, we're going to see that I get incremented here. And now it's a 1. Right here, you see this kind of this little orange yellow thing. It's showing you what's being evaluated, right? So I'm going to step over. Now it's here, and this is what it's doing. Now it's pushing another one. It's coming up here. It was 1. This is getting ready to increment this one. There we go. Now it's checking the length. It's showing you, it's walking through everything you're doing, okay? But that's when I would do into. I think if you do this, it's not going to, will it show? Yeah, it still does. Depends on where you're at, though, okay? But, very powerful tool. Obviously, and now it shows you, since you're outside of that loop, the eye's gone, right? You're outside of, it's outside of the block. You've lost scope. The scope's gone. So this is not going to on-cut this. Well, saying a reference error, eye's not defined. And this is not that it's wrong. It's because the debug, you put this as a watch and it's trying to access that and saying, hey, I don't get it. So that doesn't mean you have an error in your code. It's just, this is within the debugger. It's saying, hey, this doesn't exist. And that's true because you're outside the block of code, right? Now, some hasn't existed the whole time I put it out there because it's just now being initialized with a value, right? And now if I click this, now some has a 0, right? And this is actually a very good thing when you're, some's a good one to watch. The eye really not, it was kind of interesting just to see that increment and stuff, which you can hover over it and see it increment too. But, it just shows you what gets done first and second. It gives you a little more insight into your code. But, sum's a good one, because, you're adding to that value. So if I just keep on, I processed everything there. But, and then obviously for this, you can go through your switch statements and everything else. Let's get rid of this one. And that's another thing you kind of want to do is, make sure you kind of get rid of, you don't want to have too many breakpoints. You might get, if you're looking at a lot of things, but, be ready. It'll stop at every breakpoint. So sometimes you want to, if it's going into places you don't want to be, just get rid of your breakpoint. You just click it and get rid of it. So here So, okay, I got my breakpoint. So I'm going to just go ahead, yeah. See, it's telling me to disconnect here. I think I killed my, did I close it? No, I still have it open. Usually if you close it, it's going to, so here I'm just going to go ahead and run that again. And this time, since my breakpoint's down here, okay, so basically this is executing because it obviously, obviously this condition got met. That's the only reason it got here. And so I can see, well, what number is it? And so my numbers in my thing, I'm using modulus 2. And actually the only thing that would work for modulus 2 is the 90 here. But, let's go ahead and look. So let me hover over num, and you can see the num is 90. So, very good tool to use. And then here's your sum, because it added some of these other numbers. Well, it's basically added all of them by now. 3, 5, 45, and 90. That was my sum. So, sometimes you want to go ahead and have your watches here. Like I said, this probably isn't a relevant one. This is only relevant. You can always hover over that still, but, it's probably nice to see. Here's your sum, something you're summing. Num wouldn't be a bad one to have there. You can see which one you're at, but you can always hover if you were going through those. But, very powerful tool to use. And just wanted to kind of give you a little insight to that. And I'm hoping if I close this, it should close your debugging session up here. Let's see if it does. It did. So that's the easiest way to do it, and that's probably, you might as well just do that. And so I hope, sorry, I probably confused you with this other one. It's another way, and there's some benefits in doing it using the server itself. But you can do file system wise, and maybe it makes things simpler. So basically, you just want to start with your index.html file, hit your F5, and actually once you kind of established using the Chrome web, before, remember we had to choose that up there, but once you establish that, it's going to continue to use that, right? But if for some reason, there's times that it won't be there, you need to choose the Chrome web one, but it like I said, it'll use the file system here. All right, that's that. So I'm going to go back now. We're done with that. So I am going to go ahead and use the live server. And we're just going to run through this. All right. So what this is doing here, so you're entering numbers. So let me enter 1, 3. I'm going to put some spaces in here just to kind of show you what's going on here. Actually, it wouldn't be a bad idea to use the debugger here as well, because this is going to show you, like I put in spaces in here. What this does is we've got this dot trim. This is going to trim those spaces. So this will still work, right? Should still work fine. And it did. So basically a 1, 3 is divisible by 3. So this got executed. Then the 15 is divisible by 3 and 5. This one got executed for the 15. And then for the 90, 90 is an even number. Continue to the next iteration of the loop. Okay. So on here, and like I was kind of mentioning before, remember about break and continue? So this isn't, I have this here, but this, even though this doesn't break anything, it doesn't cause an error or anything, it's really irrelevant, because a switch statement is only going to execute that block of code when it meets that case, right? You really should be using break, is really the only one that's relevant. Continue is really only for when to execute. So here we've got a switch statement within a for loop, right? And by you doing that, it's not really relevant. Having a continue statement within your switch statement, this is just going to be a break, right? So I'm going to save that. So if the number is less than 0, if we do a -1 and hit process numbers, this just did a continue, and it's going to continue to the next one. So if I go ahead and put a good number in here now, after that -1, it's just skipping that. If the number is 0, it's just going to continue. It's going to go to the next iteration. The next iteration was for 45. It was fine. You know, like I said, we're doing a trim on this, so we can have any spaces we want. And it's taking care of that. And then always remember, let's do this. So if I put a -1 here, and then I'm going to put a number, I'm going to hit process numbers. So what's happening here? If I hit F12, F12 here, Let me look at the console. We got all kinds of other stuff here. Nothing's wrong. Nothing's wrong. So this executed. This is syntax. This is actually not an error at all. What basically you're doing is you're saying, and just kind of wanted to distinguish. We talked about breaks. You're just breaking out of a group of your code where continues going to the next iteration, right? Continues going to the next iteration. Now return is just going to return out. Once you hit that return, boom, it's coming. It's going to return from this function, and you're returning. Okay, so you got to really be cognizant where you're using different things. Here you just want to really do a continue, right? You just want to go to the next iteration. So sometimes you can mistakenly use returns. Returns, you're actually leaving that function. You're returning to the call from that function, right? Using a return. But let's go ahead and let me go ahead and do the debugger here. Let me just bring that up. Help if I hit the right thing. So I'm going to enter these same. I'm going to enter some. I think I'll do some spaces and that. And always remember, I'm going to move that over here. Always remember that you need to have breakpoints in here for it to stop. So I'm going to put a breakpoint pretty much at the beginning of this. Actually, I can just kind of get rid of this and make this big. Okay, so if I go ahead and click, I'm over here on my screen, I'm going to click process numbers. And now we're in here. And if you already have something here, obviously, if you close and open it up, some things might still be here. You want to remove them if you need to. It's up to you. This list will grow. So this is going to split because we're using those commas. It's going to split on commas. So here it's going to split on the first 100 was a 3, then a 5, and then this whole bunch of spaces in a 45, and some spaces in a 90, right? And then here you're looping in through that array, this numbers array now, right? You're looping through this array. And then every time you loop through here, didn't really want to go into. So here you're basically trimming these. So which one is this? .I. And this can also be a good one. I'm just kind of showing you some things you might do, and it depends on what you're wanting to watch. But like that. So now you're on a 3. You see the space there. So you are pushing this into a new array. You're pushing it from this here into this new array, right? And so you're on the number 3 now. We'll just go over. Now we've got the 5, right? And then that 45, and then the 90. And if you're in sometimes a big loop, you can always hit this will continue. This will continue to the next breakpoint. If you don't have a next breakpoint, it's just going to complete the rest of the function. That'll be it, right? If you have another breakpoint after this, continue will go to that breakpoint, and we're there now. And now our numbers array is going to have just numbers in it, 3, 5, 45, 90, right? So we basically converted our string array to a numbers array, and we went ahead and trimmed our string array to get rid of spaces. Okay, and then so we're going to come in here and what are we doing? So first one's going to be 3. Let's just walk through everything. Might as well. So is number less than 0? The first one is, which one are we at? Let's just put a watch here on num too. Num is 3, so let's walk through that. We'll go into. So it didn't. Number is less than 0. No, it's not. So it didn't execute this. It's going down here. It's not going to execute that one either. Now it comes down here and it's adding a sum. Sum is 0. It's going to add the number, which is 3. So sum should be 3 after that. Now we're coming down to the switch statement. Okay. And so different ways to use a switch statement. You know, I know earlier in the lecture we had days of the week, passing days. Here it's just saying switch is true. So this is kind of just a way to force yourself into the switch statement. It's based on your number here, right? It's based on your number. Your case is based on your number. Different way to do it, right? So let's go ahead and go through that. So here we're going to, is 3 modulus 3, the number 3 modulus 3, yes. So it's divisible by 3. That's true. It's going to mark that. That's going to break, right? So another thing is you got to watch how you create your switch statements, because if here you always want to, like in this case, you wanted to check 3 and 5. If one like 45 is one of them, right? So 45 is one that's going to match both 3 and 5. You have to make sure that you ask that one first. Right? You have to make sure you ask that one first. If you ask the other ones, it's going to break out and you're not going to get that. Maybe I'll just show you that here in a minute. So let's continue. All right. So that was 90. No. I kind of went past all that. That's okay. So 3, 5, we're going to go ahead and look at it though. 45 is divisible by 3 and 5, right? And that's why you got to watch how you do your, if you end up doing this, in this case, for your 45, I'm going to save that. Let me redo this debugger thing. I'm going to hit F5 here again. I got my screen. And I'm just putting in 3, 4, 45, and 90. Let's go our script thing. So let's just make sure we don't miss them. So what's going to happen here, so I'm going to click process numbers, and then we're here, and then I'm going to go ahead and continue. Get rid of them. We'll continue again. So the first one, number 3, is going to match as expected. The next one is now just realize it's since we don't have breakpoints before here, we're looping through all of this each time, so I don't have breakpoints to stop it. So it's just going to stop it when these different cases match, right? So on 5, that's going to match. So the next one's going to be on 45, right? So on 45, it's going to match this, right? which is correct. But since I moved this one down here, it's not going to say it's divisible by 3 and 5. You needed to check this one first. You have to check this one first because once this does this, it's going to move out of that one. And yep. And so then this time you can see it didn't say that 45 is divisible by both because it was in the wrong place. Something you have to watch when you do things like this in your switch statement. So, all right. All right, got that. So most of this you've kind of already have experience in doing most of this. Just kind of wanted to really bring up the idea of the breaks, the continues. Make sure you put a return. You're returning back to the calling method, whatever called your function. You're getting out of there, right? Boom, you're getting out of that function. So be cognizant of that. So let's see what else we have here. Here's an example of dividing numbers. So let me do this. Dividing by 0. And this is just showing about creating I still got debugger running, no big deal. If I don't have anything for it to stop into, it's not going to stop in here. But just remember, you kind of want to clean up, you get too many breakpoints in there, get kind of confusing, and make sure you probably should really actually kind of close down your debugger when you're done with it. But I'm already in here. I'm still in the file system. You can see it up here on the left-hand side. It's still accessing it from there. We're just going to leave it for now. It's not going to stop at anything because I don't have a breakpoint. But here we've got division. Let's see. We're doing I did want to point out this is using that. Basically, if sum is greater than 100, using the question mark, it's going to return this. If not, it's going to return this, right? And that was for the previous one we were doing. For the dividing numbers, this is basically just doing this is a try, catch, and a finally, right? So basically if the number, let's put a breakpoint here, why not? Why won't let me put it there? I don't know. That's kind of curious to me. Okay, so if num is 2, so let's go ahead and click divide. So that's a 0. If that 0 equals that 0, we're going to step into that. It catches the error. Why would that? I don't know. Maybe it's like the debugger working a little weird there. So it does do that. Division by now is not allowed. I'm going to have to look. I don't know why it's not stopping in here. I would think it would have stopped in here, but it didn't. But one thing I do want to look at here on this. So I remember in the lecture it had a return. Didn't it have a return? And I'm kind of wondering. And I copied that, but that was never did anything. It had a return. And I was thinking to myself, if you return, is it going to... I know the finally always... Let's make sure that finally really does execute. So I'm going to go ahead and do that again. Let's see if we can just get rid of the breakpoints. And just let it run. I'm going to divide. Oh, it's stuck somewhere. think it's stuck somewhere from the first time. Okay, and now I'm going to go ahead and do this again. I'm going to hit divide. Yeah, I guess it did. Okay, I was wrong. I always thought, I know, the whole concept is finally should always execute and try catch. I mean, that's, even other language. I was just wondering if JavaScript things were a little different. If you end up doing a return, that it actually would prevent that from happening, but it doesn't. So it's still going to automatically always run that, and that's what I know that's what I've always heard. As far as should be that's documented probably that way. But I've never seen anybody use a return like that, and I just kind of seen that in that example we were looking at earlier. So finally is always going to be executed. So you do a try, you do a catch, you do a finally, right? So even if you don't have an error, right? So even if you don't have an error, so let's just change this here. Even if you don't have an error, then our finally should division operation complete. We still should see that. And we do. Division operation complete. So in that case, you did a try. This, you did this try, and it did not throw an error. So you went ahead and just executed this finally block, which is division error, and that's what's expected there. And then here is just a basic a regular expression. Just a regular expression. It's kind of the same thing that we kind of looked at earlier. And this is for a phone number. So basically, this is this by signifying this / before and after. This is saying, hey, this is a regular expression, right? And then, so you're saying here, this is a /, which says use this. Don't use this as a string literal. Use this as a digit, right? So you're saying I need 3 digits, a hyphen, 3 more digits, a hyphen, and 4 digits. So this should work for this number here. Number is valid. If I get rid of anything, this should say it's invalid. And now it's invalid. So pretty basic there. Just kind of want to show you an example, and this is part of that lab assignment as well. That's all I have for today. Please let me know if you have any questions about anything, and have a good day.